So we've seen how to quickly sketch the graph of the secant. Because the secant is 1 over the cosine, we just sketch the graph of the cosine, and then we use the idea that 1 divided by tinier and tinier numbers just gets bigger and bigger and bigger, right? So if it's a tiny negative, it becomes a really big negative number. So, but if you need something a little bit more accurate than a sketch, you can also find exact values, at least for those nice angles that we've talked about. If you want to find values for the secant, think about what it's related to, which is the cosine, and just write out the values for the cosine. Remember, we can easily find the values of the cosine for multiples of pi fourths and for multiples of pi thirds, which are going to be in these basic positions here. So remember, our trick for cosine was, since it was the horizontal distance, we start out these are 0, count forward 1, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2 is 1. Count back, square root of 3 over 2, square root of, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2. And now these ones are negative. Negative square root of 1 over 2, negative square root of 2 over 2, negative square root of 3 over 2, negative square root of 4 over 2. Back to negative square root of 3 over 2. Let's see, negative square root of 2 over 2, and negative square root of 1 over 2, and to 0. So we could easily just use our little trick to remember the value of cosine at multiples of pi sixths and pi fourths, and we can then get the values for secant at those corresponding values just by taking the reciprocal, right? The secant is 1 over the cosine in every case, so we'll just find the reciprocals. Okay, so for example here, when the cosine is 0, 1 over the cosine is going to be undefined. That's going to be a problem here, and also down here. Reciprocal of 1/2 is 2. Reciprocal of square root of 2 over 2, if you rationalize the denominator, that's square root of 2. And let's see, 2 over root 3. Well, we could multiply top and bottom by root 3. We get 2 root 3 over 3. That's a little bit nicer not to have the radical in the denominator. 1 over 1 is 1. And then we have, you can see this is 2 over root 3 again, so 2 root 3 over 2 root 3 over 3 again. Then root 2, and then the reciprocal of 1/2 is back to 2. And this is going to be negative 2 and negative root 2 and negative 2 root 3 over 3. And 1 over negative 1 is still negative 1. Negative 2 root 3 over 3. And let's see, negative root 2, just from the reciprocal of that, right? The reciprocal of negative 1/2 is negative 2. We've got all the values for secant. So let's say someone asks us, well, what is the secant of 7 pi 6? Well, let's just count in. There's pi 6 and 2 pi 6 and 3, and let's see, 3 pi 6 and 4 pi 6 is 2 pi thirds, 5 pi 6, 6 pi 6, 7 pi 6, there it is, right? So this angle is 7 pi 6, so the secant must be negative 2 root 3. Oh, I messed that up. It should be negative 2 root 3 over 3. Negative 2 root 3 over 3 gives us the value. So if you can make the chart for cosine, you can figure out the cosine at any of those common angles. You can figure out the secant at those same angles where you know the cosine. Of course, those aren't the only angles, and so if it's some angle that's not a multiple of pi 6 or a multiple of pi fourths, you just have to use your calculator to approximate it. We do something similar with tangent, right? But for tangent, we need both the sine and the cosine. So if we want to make a chart for tangent, we'll have to look at the sine and the cosine in order to figure out the value of the tangent. Let me just label all these angles. We already know that I'm going to use the cosine first since it's horizontal and the sine second since it's vertical. I can put in the easy angles that we're used to here, and then we can put in the others because we know our counting program, right? The cosine starts at let's see, the cosine starts here with the cosine of 0, and then we count square root of 1 over 2 would be 1/2. Square root of 2 over 2, square root of 3 over 2, up to 1. And the sign goes the other way, right? 1/2 root 2 over 2, square root of 3 over 2. Okay, and we can, once we know those, we can fill in all the rest, because we can just reference for any of these angles over here, we can just reference what's going on in the first quadrant to figure it out. So for this angle, which is 5 pi 6, we can just reference pi 6. It's just that we go backwards and up. So backwards and up, and backwards and up. All these guys are the same, except for we go backwards and down. Right? So negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2, and negative 1/2, negative root 3 over 2. And these ones we go forward and down, so we have the same value of the cosine for each of them. We're moving forward the same amount, but instead of going up, we're going down. So we have a negative for the SINE for the sine. So 1/2 negative root 3 over 2 for all of those angles. Okay, so let's see then. We can figure out what the tangent should be at each of those common angles. So we can just take the sine divided by the cosine for each of those. So at this angle, the sine is 0 and the cosine is 1. 0 divided by 1 is 0, right? So at an angle of 0, or 2 pi, or some multiple of 2 pi, the tangent is going to be 0. Same thing over here. Sine 0 divided by negative 1 is also 0. So the tangent is 0 here, at 0 and at pi. So let's see. Here, though, the cosine is 0, also here, right? So sine divided by cosine is going to be undefined, because cosine's in the denominator on tangent. So I'm just using this idea that the tangent is the sine divided by the cosine to figure out what these values are. And then the rest of these, we can just take sine divided by cosine. 1/2 divided by root 3 over 2 reduces to 1 over root 3. Or that's the same thing if you multiply top and bottom by root 3 as root 3 over 3. Here the sine and cosine are the same, so you take a number divided by itself, you got to get 1. Here we have root 3 over 2 divided by 1/2. That's root 3 over 2 times 2, which is root 3. Okay. And we're going to get similar stuff over here as well, only in this region the sine and cosine have similar values. It's just that the cosine is negative, so the tangent is a positive divided by negative. That makes it negative. So we get negative root 3, negative 1, and negative root 3 over 3. Over here, though, the tangent's positive because the sine and cosine are both negative. So that means, say at this angle, we have, oh, I wrote that wrong, negative root 3 over 3. Okay, so here we have positive root 3 over 3, positive 1, because it's a negative divided by a negative, same number, and positive root 3. Here they're negative again, though, so we have negative root 3, negative 1, and negative root 3 over 3. So we got all the values for tangent. So suppose someone says, well, what's the tangent of, what should we do? Negative 11 pi 6. So we'll just count in. Negative 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6, 11 pi 6. There's negative 11 pi 6 right there. The tangent, we can read off our chart, is root 3 over 3, right? Or you could say to yourself, if I go backwards all but a sixth of a pi, I forgot to put in my pi there, whoops. Negative 11 pi 6 was what I was going for. That's almost negative 12 pi 6, right? That's almost a complete turn backwards. So that's the same thing as pi 6, and the tangent of pi 6 is root 3 over 3. So the point is that if you know the values of sine and cosine, which we do, we have them memorized pretty quickly at these common angles, you can find the tangent or the secant or the cotangent just by knowing what ratio you can use for sine and cosine to get those.